Hello first year, I hope you're all well. Just a little video today to go through the notes that were covered in our sound booklet last week and to introduce the new theory for this week. So we started with introducing sound as a form of energy. When we shout or clap our hands, we create this energy and that travels out across the room in the form of sound waves. Sound waves are an example of a longitudinal wave, a term which in third year you will learn more about, which means that the energy of the wave moves in the direction that it travels. How can we see sound waves? If you, for example, watch the video I posted last week of our candle flame with a loudspeaker in front of it, the candle would flicker back and forth because of the pressure difference the sound waves are creating. The candle flame behaves as it does because the forward movement of the loudspeaker pushes the air particles closer together. And this little diagram here gives us a perfect example of this longitudinal wave. The vibrations are going back and forth and the wave travelling from left to right. Keyword vibrations tells us how these sound waves are created. This here, for some of the musicians, you will know as a tuning fork. A tuning fork allows you to create a sound of a certain tone, and you could perhaps tune your key. The number of vibrations per second is called the frequency, and it's measured in a unit called hertz. Tuning forks are used to produce a note with a pure sound of only one frequency. The lower the frequency, the lower the pitch. Humans can hear between 20 and 20,000 hertz. Anything above 20,000 hertz is what we call ultrasound. So, to summarize, sound is a form of energy. The energy is transferred by waves. Sound is a longitudinal wave. Sound energy is produced by vibrations. Usually we hear sounds because of the vibrations of particles, but they can also travel through solids and liquids. Sound waves need a medium to travel through. They cannot travel through a vacuum as it contains no particles. We can use a microphone to see sound. The microphone changes the sound energy into electric energy. An electric loudspeaker changes the electric signal into sound. When we look at a sound wave on an oscilloscope, we see a wave image. The amplitude is the height of the wave. The frequency is the number of waves. So in this case, we have a height of 3 boxes, and there is one full wave from start to finish. If we increase the volume of the sound, the amplitude also increases. In this case, when the sound is increased, the amplitude goes from 3 to 5. If we change the frequency, we also change the pitch. What this means is we change the amount of waves that we see on the screen. So we have gone from 1 wave to 1, 2, 3 waves. Increase in the frequency increases the pitch. If we increase the frequency and the amplitude, we have a bigger wave with more waves in the shot. Larger amplitude and larger frequency. To summarize, volume affects how big or small a wave is. It is measured in amplitude and the unit is meters. Pitch is the frequency, how many waves per second, measured in hertz. Some experiments you're going to look at this week. If you have different lengths of rulers overhanging a table and you were to ping the ruler, you would notice that the longer the ruler, the lower the pitch, the lower the frequency. If you have a water bottle filled with water and you blow over the top of it, you hear a sound. The higher the water level, the higher the pitch, the higher the frequency. If you have straws of different lengths which you blow into, You would notice that the shorter straw has a lower pitch. These will all be available on the Firefly page, so do not worry if you're not able to write down as we go through. Cling film, the tighter that it is stretched, the longer this piece of string is or the piece of cling film is, and you ping, the sound it creates is a low sound. An elastic band, if it is in high tension, it will be a high frequency. If there's a piece of string which is thick, the thicker the string, the lower the pitch and frequency. The summary of this is that the thickness, length, and tension all affect the frequency of a sound. So I will post this in the page so you're able to open it in a document and slowly read through it on your own, along with video examples of all of the experiments above, which should make things a bit easier. Thanks.